Card is drawn from a well-shuffled deck of 52 cards. Find the probability that the card is a red card or a 6. Okay. Well, how many are both? How many of those cards are both red and 6? So out of the 52 standard card deck, I would say there are 4 6s, right? 4 6s, 2 of which are red. Okay. How many red cards are there? Well, there's 52 divided by 2. 25 plus 1, that's 26. So there's 26. And then there would be 2 6s that are black. So I think that would give us the amount, that's 28. So I think there's 28 out of 52 cards total would be the probability that this is red or a 6. But we can simplify that. 28 over 52. And turn that into a fraction. We have 7/13. Easy enough. 2 in a family of 4 children, excluding multiple births, what is the probability of having 4 girls, assuming that a girl is as likely as a boy in each birth? As likely? In this case, that would be 50%. 50% each time. So 1, 2, 3, 4. That's 1/2 times 1/2 times 1/2 times 1/2. That's 1 over 2 to the 4th. It's 1/16th chance that all of them would be girls. Number 3 says a store carries 4 brands of CD players, J, G, P, and S. From the past records, the manager found that the relative frequency of brand choice among customers varied. Which of the following probability assignments for a particular customer choosing a particular brand of CD player would have to be rejected? Why? So part A, we have the probability for J, probability of G, probability of P, probability of S. Should this be rejected? Well, the first thing we want to check is, are there any negative probabilities? Because that would be bad. And do these sum to 100? Okay, something's got to happen. So 30 plus 32 plus 21 plus 17 equals 100. So if you add those together, P of J plus P of G plus P of P plus P of S equals 1. So this checks out. There's no negative. So I would say, no, it shouldn't be rejected. In fact, it should be kept. So here we go. We should keep that one. All right, what about the next one? It says, should this be rejected? If I'm looking at part B here, I immediately notice we have a negative probability, and that doesn't make any sense. There's no such thing as negative probability. Okay, so we don't have a definition for this. So that should be rejected, certainly. Okay, and then for the third one, let's take a look at that. What's going on here? Do these sum to 132 plus 72 plus 45 plus 56? That's greater. The sum is greater than 1. So I think that should be rejected. Okay. So it's not too bad. You just have to make sure that you are checking, do you have negative probabilities and do they sum to 1? Okay. Small combination lock on the suitcase has 3 wheels, each labeled with 10 digits 0 through 9. If an opening combination is a particular sequence of 3 digits with no repeats, what is the probability of a person guessing the right combination? Okay, we see no repeats. No repeats. And we had a problem like this in the previous homework. Okay, so 1, 2, 3. First, second, third number. You have 10 choices, 9 choices, 8 choices. 9 times 8, 72 times 10, 720. So we have 720 possible combinations. Probability of someone guessing out of those would be, I guess, 1 out of 720. So best of luck to that person. I would say they win the prize if they guess it. Experiment consists of rolling 2 fair dice, adding the dots on the 2 sides facing up. That's just, we're going to play a normal 2 dice game, right? Assuming each simple event is likely as another, find the probability that the sum of dots is greater than 3. Okay. So we're just going to play with 2 dice as normal. We want greater than 3. Well, we can go straightforward, but I think it would be easier with these numbers to kind of think about what we don't want. With 2 dice, what's possible? We could roll 2 ones, and that would give us a sum of 2. Or you could roll 3 with 2 and 1 and 1 and 2. So those are the only possible outcomes that we want to exclude. How many possible outcomes are there? There's 36 possible outcomes, right? We can have 6 by 6 choices. So the sample space is 36. We only want to exclude 3 of them. So I think the probability of sum is greater than 3. We're just going to take 36 minus 3 over 36, which is 33 over 36. Which is 11 twelfths. There's 11 out of 12 that could possibly occur. For that, I just think it's easier to count the ones we don't want than to count the ones we do want, because we would have to count 33 different ones. Okay, here, same setup. Find the probability the sum of dots is 10 or 7. Okay, last time we were talking about 3. Probability sum is 10 or 7. How can that occur? How can you get a 10? Well, with a 1, you can't roll a 9, so that doesn't count. 2 and 8, 8 doesn't exist. 3 and 7, 7 doesn't exist. But 4 and 6, I think would be the first one you could possibly do for 10. And then 5 and 5, of course. 6 and 4. I think those are the only ways you could get 10 when rolling 2 dice. What about a 7? There's lots of ways to get the 7. 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. All right, how many ways is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different ways. Out of how many? So I think it's 9 out of 36, which is 1/4. Okay. Easy to do if you know what to do, but you just got to count how many different ways. Okay. Number 7, if you were dealt 6 cards from a shuffled deck of 52 cards, find the probability of getting 4 queens and 2 kings. Okay. So, how many queens are there? Well, there's only 4. So that's 4, choose 4, which is just 1. 2 kings, there's 4. 4, choose 2. It's 4 factorial, 2 factorial, 4 minus 2 factorial, which is 6. Okay. 4 times 3 divided by 2 is 6. Okay. So the top is just 6. So the probability of 4 queens and 2 kings. Out of the standard deck, we just have 1 times 6. Okay, but what would be our denominator? It's 52 cards, and we're choosing 6. So that's 52, choose 6. Okay, I'm gonna let the calculator help me for that, but that's what we need to find. 6 divided by 52, choose 6. All right. Let's ask the calculator what it thinks. Here's the calculator. Okay. I know what 6 is, but what's 52? 52, choose 6. All right, it's that big number right there. That's what we want. Okay, so we want to go 6 divided by that number. Oops, I hit the wrong button, excuse me. 6 divided by 52, choose 6. An incredibly small number. Can my calculator turn that into a fraction? It cannot. Okay, so my calculator is not strong enough to turn that into a fraction. So how can I do it? Well, let's go back. 52, choose 6. I know I have 6 on the top. So I notice that this is even, so I could at least divide by 2. And then I would have 3 over that number. And that actually turns out to be the answer. Okay? So since this is not divisible by 3, okay, then this is my answer. So we're just doing basic arithmetic at that point, but 3 over 1, 0, 1, 7, 9, 2, 6, 0 is our answer as a fraction, right? But your calculator might be able to do it, so it's worth checking. Okay. Suppose you have 6 female and 6 male applicants have successfully screened for 5 positions. If the 5 positions are filled at random from the 12 finalists, what is the probability of selecting 3 female and 2 males? Okay, so part A, 6, choose 3, 6 male, 2 male, so that would be times 6, choose 2, all over, how many total? 12 finalists, choose 5. Okay. That's part A. You can see what I got there. For part B, the probability of selecting 4 females, 1 male, right? We have 6 for my numbers. We're choosing 4. We have 6, choose 1 from the males. We have 12 total, and we're going to choose 5. So that would be part B. Part C, we are choosing at least 4 females. So at least, it's going to be more than one step. Okay, so 6, choose 4 times 6, choose 1. All over 12, choose 5. But that's, we want at least 4. So I could choose all females, no males. So I should add that on. Okay, that would be the other option. So that would be giving me part C. Okay. Easy enough if you know what to do, but you have to build it and watch out for that at least, at most. That can complicate things. Okay, for 9, it says town council has 13 members, 8 Democrats, 5 Republicans. If the president and vice president are selected at random, what is the probability that they are both Democrats. Okay. Vice president and president. That sounds like order matters to me. President, vice president. Okay. So if that's the case, that would be 8 times 7, which is 56. But how many total do we have here? Well, I have 13 members. So first, second, or president, vice president would be 13 by 12. Okay. What is that? 156. 6 over 156 approximately equals 0.359. Okay. Part B says probability Republicans make up the majority of it's approximately, and this is a 3-person committee. So that's like a group. Okay, not a specific role, but a group. So we want to think, how many groups can we make with majority of being Republican? All right. How many Republicans do we have? In my numbers, we have 5. So that would be 5, choose 2, and then we would still choose a Democrat. 8, choose 1. You could also just choose all Republican. That would be the majority. And over 13, choose 3. That would do it. Okay. So I'm gonna put that in my calculator, but that's how we build it. And see what happens. 5, choose 2. Minus, and then 8, choose 1 is just 8. Plus 5, choose 3. Divided by 13, choose 3. There we have. And I did have to round a little bit. 0.31, and if we round, the 4 becomes 8. There you have it. Venn says, refer to the Venn diagram to the right of the events A and B is equally likely sample space of S. Find the indicated probability. Find the probability of A intersect B complement. Okay, we want the opposite of A and B. Well, what is A and B? A and B is right here. For my numbers, it's 10. So we want the opposite of that 10. Well, that would be 1 minus 10 out of 100. How much is that? 100 minus 10 for 100, 90, 100. Okay. Or just 0.9. That's what the complement does. It gives us the opposite. So it's everything else. Okay, number 11 in the lottery game, a single ball is drawn at random from a container that contains 25 identical balls numbered 1 through 25. Find the probability that the number drawn is even or is a multiple of 7. Okay, well, what would be in our set then? Even numbers, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, and then they said also a multiple of 7. So we need to add in 7 there. And we already have 14. And we're going to put in 21. That's it, really. It's our set. Okay, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the number of that set is 14. We have 25 total numbers. So it's just 14 over 25. Number 16 says a single card is drawn from a standard 52 card deck. Calculate the probability and odds for the following event. A king or heart is drawn. How many kings are there? 4. How many hearts are there? 13. How many king hearts are there? 1. So that means how many cards are we actually talking about? We're talking about 16 cards total. All right, how many total cards do we have? 52. So 16 50-seconds reduces to 4/13. So that's the probability of a king or a heart. Find the odds for an event. The odds of an event. Probability of the event divided by the probability of the complement is the odds. That's the odds. Okay, what is the probability of the event? 4/13. What's the complement? 1 minus 4/13. 4/13. Then 13 minus 4 over 13. 4/13 over 9/13. 4/9. There you have it. Odds of an event occurring is the probability of the event over the complement of the event. Number 17, a shipment of 60 inexpensive digital watches, including 9 that are defective, is sent to the department store. The receiving department selects 10 at random for testing and rejects the whole shipment if 1 or more in the sample is found to be defective. What is the probability the shipment is defective? Okay, so we have 9 that don't work. We have 60 total. All right, so how many do we have that work? Well, 60 minus 9 is 51. They're working just fine. Okay, and we're choosing 10. Choose 10, right? All right, so what's the probability that it was not rejected? The probability of it not being rejected would be 51, choose 10, over the total, choose 10. Let's see what that is. So that is 51, choose 10, divided by 60, choose. So that's the probability it doesn't get rejected. We want the complement. We want rejected. I claim we want 1 minus 0.169471099. 1, what is that? 1 minus previous answer. And this is the probability it does get rejected, which is 0.83052090009, and so on. We can round that to 83%. Okay. In order to test a new drug for adverse reactions, the drug was administered to 1,000 test subjects with the following result. 40 subjects reported that their only adverse reaction was a loss of appetite. 90 reported that their only adverse reaction was loss of sleep. 700 reported no adverse reactions at all. If this is to be released in general use, what is the empirical probability that the person using the drug will suffer from both loss of appetite and sleep? Okay, so I think they're asking for what is the intersection. Okay, let's say that this is appetite and this is sleep. Well, there's 700 that have no problem at all. There's 1,000 total. So that means we have 300 in the union, but I don't know what their intersection is. That's what I'm looking for. Okay. So before we said, all right, appetite and sleep is appetite plus sleep minus their union. So we would have 40 plus 90 minus the 300, okay? And that's going to give us negative 170. The negative is because we're talking about loss of appetite. We want both of them. So that's 170 over 1,000. Cancel zeros. 17 100s. There you go. Okay. Hope this was helpful to you.